Section 1. The dawn of thinking machines in combat. Autonomous weapons systems, often called AWS, represent a new frontier in military technology. These are not your everyday tools or simple machines. Instead, AWS are weapon systems with artificial intelligence. This AI allows them to independently search for, identify, target, and even neutralize enemy threats. The key word here is independently. This means they can perform these complex tasks without direct, moment-by-moment human control. Think of them as machines that can make some combat decisions on their own, based on their programming and the data they gather from their surroundings. This capability marks a significant shift from remotely piloted or automated systems, pushing us into uncharted territory. Real-world examples are beginning to emerge, moving from science fiction to battlefield reality. We are already familiar with drones or uncrewed aerial vehicles, UAVs. Many current drones are remotely piloted by humans. However, the technology is advancing rapidly. Some newer drone systems possess increasingly autonomous functions, like tracking targets or returning to base if communication is lost. Beyond the skies, researchers and military developers are also exploring ground-based robot soldiers. These could be machines designed to patrol areas, engage targets, or even breach enemy defenses. The vision for these systems often includes a high degree of autonomy, enabling them to operate in dangerous environments where sending human soldiers would be too risky. The defining characteristic of an AWS is its capacity for autonomy in the critical functions of warfare. These critical functions specifically involve the selection and engagement of targets. An autonomous system might be programmed with certain rules of engagement. It could be given a geographical area to monitor or a list of target characteristics. Once activated, it could then operate within those parameters, making decisions that were once exclusively the domain of human soldiers or their commanders. This ability to act without a human in the loop for every action is what makes AWS so powerful, and also so deeply concerning to many observers and ethicists around the globe. The implications of such technology are profound, touching upon military strategy, international law, and fundamental ethics. As these systems become more sophisticated, they promise to change the very nature of conflict. Proponents might argue for their potential to increase precision or protect soldiers' lives by sending machines into harm's way. However, a growing chorus of voices raises urgent questions about accountability, the risk of errors, and the moral permissibility of delegating life and death decisions to algorithms. Understanding what AWS are and how they function is the first crucial step in navigating this complex and rapidly evolving landscape of modern warfare. Section 2. Degrees of independence. Understanding autonomy in weaponry. The term autonomy in weapon systems is not a simple on or off switch. It exists on a spectrum, a range of capabilities. It is vital to understand these different degrees of independence to have a meaningful discussion. At one end, we have automated systems. These systems can perform pre-programmed actions in response to specific triggers. Think of a defensive phalanx CIWS on a naval ship, which automatically detects and fires at incoming missiles. While fast and effective, its actions are rigidly defined by its programming. Human operators set its parameters and can override it, making it more of a tool that executes a specific preset task very quickly. Moving along the spectrum, we encounter semi-autonomous systems. These systems can perform a broader range of tasks with more flexibility. For instance, a semi-autonomous drone might be able to navigate to a designated area on its own. It might even identify potential targets based on its programming. However, it would still require a human operator to confirm the target and authorize engagement. This is often referred to as keeping a human in the loop. The machine does much of the legwork, such as searching and identifying, but the final, critical decision to use force rests with a human. This level of autonomy is already present in many modern military systems today. The most debated and ethically challenging end of the spectrum is fully autonomous weapons systems. These are systems designed to select and engage targets without any human intervention once activated. They would operate based on complex algorithms and machine learning, allowing them to adapt to changing circumstances and make decisions in dynamic environments. Such a system, often referred to as a lethal autonomous weapon system, or LAWS, would embody the concept of a machine making life or death decisions. It is this category that raises the most profound concerns about the loss of human control over the use of force and the potential for unintended consequences in the theatre of war. Understanding these distinctions is crucial because the level of autonomy directly impacts the ethical and legal questions raised. An automated defensive system firing at an incoming rocket is viewed very differently from a fully autonomous drone patrolling a city and deciding on its own who constitutes a threat and should be engaged. The debate around AWS is largely focused on preventing the development and deployment of systems that cross a critical threshold where meaningful human control over individual attacks is lost. Defining that threshold and understanding the nuances of autonomy are central to navigating the future of these powerful technologies responsibly and carefully. Section 3. Forging the Future. Current AWS Development Landscape. The development of autonomous weapon systems is not a distant future prospect. It is happening right now. Several technologically advanced nations are investing heavily in artificial intelligence and robotics for military applications. Countries like the United States, China, Russia, Israel, South Korea, and the United Kingdom are all known to be researching and developing various forms of AWS. This development is driven by a perceived strategic advantage, the potential to reduce risks to their own human soldiers, and the relentless pace of technological innovation. The race to develop more sophisticated AI for military use is a significant aspect of modern geopolitical competition, pushing boundaries quickly. Specific examples of systems with increasing autonomy are already visible. We see loitering munitions, sometimes called kamikaze drones, which can be launched to autonomously search a designated area for targets that match certain pre-programmed criteria. Once a target is identified, the munition can then engage it. While some current systems may require final human authorization, the technological trend is towards greater autonomy in these functions. Similarly, automated sentry guns are being developed and, in some cases, deployed along borders. These systems can detect movement or specific signatures and, depending on their configuration, could potentially engage threats without direct human input for each shot. The core technologies underpinning AWS development are rapidly advancing. Progress in machine learning, computer vision, sensor fusion, and navigation algorithms are all contributing factors. Machine learning allows systems to learn from vast amounts of data, improving their ability to identify targets or navigate complex environments. Enhanced sensors provide richer data streams for AI to process. This convergence of technologies is enabling the creation of machines that are more aware of their surroundings and more capable of making complex decisions independently. The challenge lies in ensuring these decisions align with human intentions and ethical principles, especially in the chaotic and unpredictable environment of warfare. However, it is important to note that fully autonomous systems capable of operating with human-like judgment in complex, unrestricted combat scenarios, are still largely in the developmental or conceptual stages. Most currently deployed systems that are labeled autonomous operate under significant constraints, often in defensive roles or with humans on the loop, monitoring and able to intervene. The debate centers on the trajectory of this development. Are we inevitably heading towards machines that make the ultimate decision to kill? And what steps should be taken now to guide or limit this progression towards greater autonomy and lethal force? Section 4. On the ground and in the air. Deployment of autonomous systems. The deployment of systems with autonomous features is already a reality in modern militaries, though full autonomy in lethal decision-making is still contentious and less common. We see automated defensive systems widely deployed. For example, naval vessels are equipped with systems like the aforementioned Phalanx CIWS, which can autonomously detect, track, and engage incoming anti-ship missiles or fast attack craft. Israel's Iron Dome system also uses sophisticated radar and AI to intercept rockets, operating with a high degree of automation to protect civilian areas. These systems are generally considered defensive and operate under strict rules of engagement set by humans, primarily reacting to immediate, clearly defined threats. In the aerial domain, drones are increasingly incorporating autonomous functions. Beyond simple autopilot, some surveillance drones can autonomously follow pre-programmed flight paths, track moving targets for extended periods, and even perform autonomous takeoffs and landings. While most armed drones currently require a human operator to authorize weapons release, the technology for autonomous target recognition, ATR, is advancing. The concern is that these ATR capabilities could be paired with engagement authority, leading to fully autonomous strike missions. Some nations are reportedly exploring concepts for swarms of drones that can coordinate autonomously to overwhelm enemy defenses or conduct surveillance over wide areas. On land, the deployment of fully autonomous lethal systems is more limited and controversial. However, automated sentry robots have been tested and, in some instances, deployed in border security roles, such as along the Korean demilitarized zone. These systems can use sensors to detect intrusion and may be armed. The extent of their autonomy in engaging targets varies and is often kept confidential. The development of robotic ground vehicles, RGVs, with autonomous navigation and potentially armed capabilities is also an active area of research. These could be used for reconnaissance, logistics, or even combat support, reducing the danger to human soldiers in high-risk operations. The trend indicates a gradual increase in the autonomy given to military systems across all domains, air, land, and sea. This increase is often incremental, with new autonomous features being added to existing platforms or incorporated into new designs. While proponents argue this enhances efficiency, speed, and soldier safety, it also steadily pushes the boundaries of human control over the use of force. The critical question for deployment is not just what can be automated, but what should be automated, especially when it involves the lethal application of force, and where the line for meaningful human control must be firmly drawn and maintained. Section 5. The Moral Compass Malfunction. Ethical Dilemmas of AWS. The most profound ethical dilemma surrounding autonomous weapon systems centers on the delegation of life or death decisions to machines. Human soldiers are expected to operate under international humanitarian law, which includes principles like distinction, differentiating combatants from civilians, and proportionality, ensuring an attack is not excessive relative to the military advantage gained. These principles often require complex, context-dependent judgment, empathy, and an understanding of human intent. Can an AI, which lacks genuine understanding, consciousness, or compassion, truly make such nuanced moral calculations in the ambiguous and chaotic environment of a battlefield? Many ethicists and human rights organizations argue that it cannot. The absence of human oversight at the critical moment of engagement is a core concern. If an AWS makes an error, misidentifying a civilian as a combatant, or launching an attack that is disproportionate, there is no human conscience to intervene, no possibility for a last-second change of heart based on new information, or a gut feeling that something is strong. Machines operate based on algorithms and data. They do not experience doubt, pity, or mercy. This moral outsourcing to algorithms raises fundamental questions about what it means to take a human life, and whether a machine can ever be considered a legitimate moral agent capable of making such a decision. This is the heart of the meaningful human control debate. Furthermore, the reliance on AI in AWS introduces risks of bias and error. AI systems are trained on data, and if that data reflects existing biases, like in identifying certain groups as threats, the AI can perpetuate and even amplify these biases on the battlefield, potentially leading to discriminatory targeting. Algorithms can also be susceptible to unforeseen errors or manipulation, especially when faced with novel situations not encountered during their training. The complexity of modern AI, particularly deep learning models, can make their decision-making processes opaque, a black box phenomenon, where even the programmers may not fully understand why a system made a particular choice, further complicating ethical assessment. The potential for conflict escalation is another significant ethical worry. The speed at which AWS could operate might compress decision-making timelines, forcing adversaries to also rely on autonomous systems to keep pace. This could lead to rapid, automated exchanges of fire with minimal human deliberation, potentially escalating conflicts before diplomats or commanders have a chance to intervene. If nations perceive a first-mover advantage in deploying highly autonomous systems, it could trigger an AI arms race, making the world a more dangerous and unstable place. The ethical imperative, therefore, is to carefully consider these profound risks before such technologies become widespread and irreversible. Section 6. When machines err. Accountability and escalation risks. A critical unresolved issue with autonomous weapons systems is accountability. If an AWS unlawfully kills civilians or destroys protected property, who is responsible? Is it the programmer who wrote the code? Is it the manufacturer who built the machine? Is it the commander who deployed the system? Or is it the AI itself, an entity with no legal standing or capacity for punishment? This accountability gap is a serious challenge to existing legal frameworks, both domestic and international. Without clear lines of responsibility, there is a risk that war crimes or other violations committed by AWS could go unpunished, undermining justice and the rule of law in armed conflict. The risk of unintended consequences from AWS actions is substantial and multifaceted. Software, no matter how advanced, can have bugs or vulnerabilities. These could lead an AWS to behave in unpredictable or catastrophic ways, especially in the complex and data-sparse environments of real-world combat. Furthermore, autonomous systems could be susceptible to hacking or spoofing by adversaries, who might trick them into attacking friendly forces or civilian targets. The interaction between multiple autonomous systems, potentially from different nations with different programming, could also lead to unforeseen emergent behaviors and accidental escalation, creating a battlefield far more chaotic than anticipated by human planners. Beyond individual errors, the widespread adoption of AWS could fundamentally alter the dynamics of conflict escalation. The perceived ability of AWS to conduct operations with reduced risk to one's own soldiers might lower the threshold for resorting to force. Nations might be more willing to engage in hostilities if they believe machines will bear the brunt of the fighting. Moreover, the speed of autonomous warfare could outpace human diplomatic efforts. If conflicts are fought at machine speed, with algorithms making decisions in microseconds, opportunities for de-escalation, negotiation, or surrender might be lost. This creates a dangerous potential for conflicts to rapidly spiral out of control, beyond human ability to manage them effectively. The fear of an AI arms race also contributes to escalation risks. As one nation develops and deploys more advanced AWS, other nations will feel compelled to do the same to avoid falling behind. This competitive dynamic can lead to a relentless pursuit of increasingly autonomous and potentially more destructive weapon systems without adequate consideration for the long-term strategic stability or the ethical implications. Such an arms race would consume vast resources and increase global tensions, making conflicts more likely and potentially more devastating. Avoiding this scenario requires proactive dialogue and efforts towards international cooperation and arms control measures for AWS. Section 7. Drawing the lines. The urgent need for regulation. The rapid advancement and potential proliferation of autonomous weapons systems necessitates a robust international dialogue on regulation and oversight. Waiting until these systems are widely deployed will be too late. The time to establish clear boundaries is now, while the technology is still maturing. International agreements are crucial because the impact of AWS will not be confined by national borders. The nature of warfare itself is at stake, and a global consensus is needed to prevent a future where machines autonomously make life or death decisions without meaningful human control. Such agreements could range from outright bans on certain types of AWS to limitations on their capabilities and uses. The development of effective regulation faces significant challenges. Defining autonomy and meaningful human control in legally precise terms is a complex task. Different nations have varying strategic interests and perspectives on the military utility of AWS, making consensus difficult to achieve. Some states may resist limitations, fearing they will be put at a disadvantage. However, historical precedents in arms control, such as treaties on chemical or biological weapons, demonstrate that international agreements on problematic weapons are possible when the humanitarian risks are deemed unacceptable by the global community. The potential for AWS to destabilize global security and violate fundamental ethical principles provides a strong impetus for such collective action. Ethical frameworks must be central to any regulatory efforts concerning AI in warfare. These frameworks should go beyond purely technical specifications and address the moral dimensions of using autonomous systems in combat. They should affirm principles such as human responsibility for the use of force, the importance of distinguishing combatants from non-combatants, and the need for proportionality in attacks. Such frameworks can guide national policies, research and development priorities, and military doctrine related to AWS. They can also provide a basis for public debate and help to ensure that technological development remains aligned with human values and international humanitarian law. Ultimately, the goal of regulation and oversight is to ensure that humans retain control over decisions to use force, particularly lethal force. This means prohibiting systems that can independently select and engage targets without the possibility of timely human intervention and judgment. It also means establishing clear lines of accountability for the actions of any weapon system. International cooperation involving governments, military experts, scientists, ethicists, and civil society is essential to navigate the complexities of AWS and to forge a path that safeguards humanity from the unintended and potentially catastrophic consequences of unchecked autonomous warfare. The future of peace and security may depend on it. Section 8. Guiding Principles, Ethical Frameworks, and Human Control. Crafting robust ethical frameworks for artificial intelligence in warfare is a paramount task for the international community. These frameworks must be built upon foundational human values and the existing laws of armed conflict. A core principle should be the unwavering necessity of meaningful human control over the use of force. This means that humans, not machines, must always make the critical decisions about when, where, and against whom lethal force is applied. This control should be substantive, not merely a symbolic sign-off on a machine's predetermined course of action. It requires humans to have sufficient information, understanding, and time to make reasoned judgments. Such ethical frameworks should explicitly address the principle of distinction. AI systems, however advanced, struggle with the nuanced contextual understanding required to reliably distinguish between a combatant and a civilian, especially in complex urban environments or situations involving dual-use objects. The framework must insist that any system deployed is capable of making this distinction with an extremely high degree of reliability, and that human oversight is present to validate these critical assessments. Similarly, the principle of proportionality, which weighs military advantage against potential harm to civilians and civilian objects, demands human judgment that considers a wide array of factors often beyond an algorithm's grasp. Accountability is another cornerstone of any viable ethical framework. There must be clear legal and moral responsibility assigned to humans for any actions taken by autonomous systems. This means rejecting any notion that the machine itself can be held accountable. Commanders who deploy AWS, operators who supervise them, and even developers and manufacturers must understand their roles and responsibilities in ensuring these systems are used lawfully and ethically. Establishing chains of command and responsibility for the entire life cycle of an AWS, from design to deployment and use, is crucial for maintaining ethical boundaries and ensuring that violations can be investigated and addressed properly. Furthermore, ethical frameworks should promote transparency and predictability in the behavior of AWS. Black box algorithms, where the decision-making process is opaque even to its creators, are unacceptable in systems that can apply lethal force. There needs to be a way to understand, audit, and verify why an autonomous system made a particular targeting decision. This is essential not only for accountability, but also for building trust where appropriate, and for identifying and correcting errors or biases in the system. The development of AI for military purposes must prioritize safety, reliability, and adherence to strict ethical guidelines above all else, ensuring technology serves humanity, not the other way around. Section 9. Warfare Transformed. The future of AI and our collective responsibility. Artificial intelligence is poised to revolutionize warfare in ways we are only beginning to comprehend. Its future impact could be as transformative as gunpowder or nuclear weapons. AI could accelerate the speed of combat dramatically, process vast amounts of intelligence data far beyond human capacity, and enable new forms of attack and defense. We might see intelligent swarms of drones, overwhelming adversaries, AI-powered cyber attacks that cripple infrastructure in seconds, or sophisticated AI battle managers coordinating complex operations across multiple domains. This revolution brings both potential benefits and profound perils that demand our immediate and sustained attention as a global society. On one hand, proponents suggest AI could lead to more precise targeting, potentially reducing collateral damage and civilian casualties if systems are designed and constrained appropriately. AI could also enhance the protection of one's own forces by undertaking dangerous tasks like reconnaissance in hazardous areas or mine clearance, thereby saving human lives. AI-driven logistics and predictive maintenance could make military operations more efficient. These potential upsides are often cited by those advocating for continued research and development. However, these benefits are contingent on perfect design, flawless operation, and ethical deployment, conditions that are incredibly difficult to guarantee in the fog of war. The overarching ethical challenge remains maintaining human control and moral agency in an increasingly AI-driven battle space. As AI systems become more capable and more deeply integrated into military operations, there will be immense pressure to delegate more decision-making authority to them, especially in time-critical situations. Resisting this pressure and ensuring that humans remain ultimately responsible for acts of war is a critical ethical imperative. The allure of technological superiority must not lead us to abdicate our moral responsibilities or to create a future where unaccountable machines wage war according to programmed directives, devoid of human compassion or judgment. Therefore, a collective call to action is urgently needed. Public awareness of the implications of AI in warfare must be significantly increased. Governments, researchers, military establishments, ethicists, and the public must engage in open and honest collaboration to address these complex issues. We need to foster a global dialogue aimed at establishing clear international norms, ethical guidelines, and legally binding regulations for the development and use of autonomous weapons systems. The future of warfare is not predetermined. It will be shaped by the choices we make today. Engaging thoughtfully and proactively with the ethical challenges of AI in warfare is essential to ensure a more secure and humane future for all.